Welcome to the video for lesson 5-6, inequalities in one triangle. This one says students will be able to use inequalities involving angles and sides of triangles. So we're going to compare and figure out what sides are bigger than others, what angles are bigger than others, based off of what we are given. So a lot of this today is based off of something called the comparison property. It says the angles and the sides of a triangle have special relationships that involve inequalities. So the comparison property is just saying this. If A is equal to two things added up, and I know if A is equal to two things added up, and I know that C is positive, that must mean that B is smaller than A. I know that if this is true, then this must be two smaller numbers. The only way to add two positive numbers up and get something bigger is if A is the biggest thing in all of this. This says numbers. Okay? Let me prove what I'm talking about here. All right, so if I'm given that this is a true statement, A is equal to two other numbers added up, and I know that C is positive, that means that A has to be bigger than B. All right, so here's our given. Okay, what we know right now is here's one of our givens. We know that C is positive. So if we know C is positive, then we can add on to that B to both sides. I know that B plus C will be greater than B plus 0. Since C is positive, I know that B plus 0 is smaller than B plus C, since I'm adding instead of subtracting. So that's just adding B to both sides. And now this is the part that A is equal to, all right? So I'm just dropping off the 0 here by identity property, okay? Adding 0 to itself is an identity. Adding 0 to something doesn't change the value, okay? So now I know that A is equal to B plus C, all right? And I know that B plus C is bigger than B, so by a little bit of substitution, A has to be bigger than B. All right, since B plus C is greater than B, I could swap B in, and I know that A is greater than B by substitution. So what it's saying is if you're adding up two positive numbers, the sum is going to be bigger than both of those other two. All right, so it should make some sense. So the triangle exterior angle theorem is an example of this. All right, the measure of each exterior angle. So what we talked about before was this exterior angle of the triangle being the total of angle 2 plus angle 3. Well, that means angle 1 will be the largest because it's adding up two angles that we know are positive. We don't let angles be negative answers. Okay, so here's a little corollary to it then. All right, like I just said, the outside angle should be the biggest. The measure of an exterior angle is greater than the measure of each of its remote interior angles. All right, the angle on the outside will be the biggest. Okay, this is the largest number of the three. Okay, so you might get some questions about explaining why certain numbers or certain angles are bigger than others. If I can get angle 1 to be equal or greater than 2 or equal to 2 plus something else, that means 1 has to be bigger by comparison. So if I look at angle 1 right here, angle 1 is an exterior angle. That means that the measure of angle 1 is equal to the measure of angle 2 plus the measure of angle 3. Okay, so what I know is since that is an exterior angle, that the two remote interiors, 2 and 3, add up to be equal to 1. So if 1 is equal to 2 plus 3, and since all of these angles are positive, that means that angle 1 has to be bigger than angle 2 by the comparison property. The comparison property is what you can use when you get something like this. Angle 1 is equal to angle 2 plus something else. So that's kind of my goal here. I need to be able to set up angle 1 to be equal to 2 plus something else. All right? So in this example, I know, first off, that angle 1 is equal to 3 plus 4 because that's the exterior angle theorem, triangle exterior angle theorem, okay? I want to get 2 in there somehow. These are parallel lines this time, which means 2 is congruent to 3, or angle 2 equals angle 3 by alternate interior angles, okay? If I have 2 and 3 equal to each other, I can swap 2 in for 3 whenever I want, which means I can say that angle 1 is equal to angle 2 plus angle 4. What I'm trying to do for comparison property is get angle 1 equal to 2 plus something else. And that's what I have here. This means angle 1 is bigger than angle 2 by comparison. Okay, so you're trying to get the comparison property to show you if this is the total of 2 numbers added up, then the one that's all by itself has to be the largest number. Okay. All right, last example of this. All right, why is 2 bigger than 3? All right, well, here's 2. All right, I know that 2 is congruent to 1 by the isosceles triangle theorem. So I know that isosceles triangles with 2 congruent legs have 2 congruent base angles. So I know that angle 1 is equal to angle 2 because it's an isosceles triangle. Okay, I also know that angle 1 is equal to since this is an exterior angle here, okay, I know that angle 1 is equal to 3 plus 4 by the triangle exterior angle theorem, okay? Since 1 and 2 are the same thing, I can take 2 and I can substitute. Angle 2 is equal to angle 3 plus angle 4 substitution. All right, and that means by comparison, angle 2 has to be bigger than angle 3. Since angle 2 is equal to 3 plus something else, I know that angle 2 has to be larger. Okay, that's not the main thing you'll do today, but that's using comparison property to decide what is bigger and what is smaller. Okay, that leads into what we're talking about today. All right, so this theorem, you don't need to know the name, but you need to know how to use it. If 2 sides of a triangle are not congruent, so if we don't have an isosceles situation, the larger angle in a triangle is opposite the longer side. So what that means is big angles are across from big sides, and small angles are across from small sides or short sides. Okay, so what the application of that is if they give you a bunch of side lengths, you can decide which angles are the biggest and which angles are the smallest. So since this one wants to go from smallest to largest, the smallest angle will be across from the shortest side. So 2.9 is the shortest side on this triangle, which means across from that, angle B is the shortest angle. The next shortest side is here at 3, which is across from angle A. And then that leaves the biggest side, 3.1, to be across from angle C, angle C, which is the largest angle. Okay. Same type of idea here. All of these have a y in it. All right, 3y, 4y, and 5y are my side lengths. If y is the same letter for all of those, that means it doesn't really matter what y is. 3 times y, since we know it's going to be positive, 3y, it should be the smallest side, which makes angle J the smallest angle. All right, the next smallest would be 4y, which is across from angle L. That's the next smallest. The largest side, the hypotenuse of this triangle, will be across from angle K, which is my largest angle, that 90-degree angle. Okay, I'm going to keep going here. Same situation, same setup with the adding. We have x, x plus 1, and x plus 2. So we know that x is going to have to be positive. So x with nothing added to it will be the smallest. Angle Z comes first. X plus 1 would be across from angle X, which will be our next smallest, and then our largest has to be x plus 2, which is across from angle y. Okay. And then the last one here, I have a right triangle, which means this is the hypotenuse, which means that has to be the longest side. Okay, even if they don't give us that side, we can still figure it out. 5 is the shortest, which is across from Q. The next shortest is 12, which is across from S. And then the longest is the hypotenuse, regardless of what it is. It'll be 13, but even if you don't know that, you know that 90 has to be the biggest angle in the triangle. Okay, so that's using the angles using the side lengths to figure out how long or how big the angle should be, which one should be smallest, which one should be largest. It works the other way as well. All right, it's saying the same type of setup. If two angles of a triangle are not congruent, so not isosceles here, the longer side is opposite the larger angle. So it works the other way too. If you know that this is the big angle, that makes this the big side. If you know that this is the small angle, you know that this is the small or the short side. Okay, the biggest angles will create the biggest sides, and the smallest angles will create the smallest sides, the shortest sides. Okay, so same type of question we get here. It says list the side of each triangle in order from shortest to longest. Okay, I know that I have a 44 and a 46. Those two add up to 90, which tells me this one has to be 90 if all three triangles need to make 180 together. All right, since I'm going shortest to longest, all right, the smallest angle is 44. Across from that is the side that is called RS, which would be the shortest side. The next smallest angle is 46. Across from 46 is QR, which is the next shortest side. The longest side will be this time across from the 90, which is the hypotenuse, which is always the longest side of a right triangle. The longest side this time should be QS. Okay, over here we have a 54 and a 61. Together that makes 115, which means that this last angle has to be 65. Okay, then we would have 180 for a total. All right, so with that information, we can begin by finding the smallest angle, which is across from the shortest side, which is MO. The next smallest angle is 61, which is across from the next shortest side, which is NO. And then the longest side is across from the largest angle, which is NM. Okay, moving on. This time they don't give you the picture. You can certainly draw it. That would help you figure out quickly where everything should go. All right, so just put an A, B, C anywhere you want, and then label the picture how they said. So by A, we need a 99. By B, we need a 44. By C, we need a 37. Okay, the smallest angle is 37, which means AB across is the shortest side. Next smallest angle is the 44, which means the next shortest side is AC. And then the longest side is across from the 99, which is the BC. All right, so on these, if it helps you to draw a picture, then you can certainly do so. Okay, this one says, which choice shows the sides of TUV in order from shortest to longest? Now it's multiple choice. All right, 58 and 62 are going to add up to 120 together, which means this last angle has to be 60. All right, so I need from shortest to longest. 58 is the shortest, which means TV should be first. So any answer that TV is not first has to be out. All right, then the next step would be to look at what's the next shortest. I'm looking for UV to be the next shortest, so it looks like A has it and D would be backwards. Okay, so that's how you might use inequality to figure out which sides should be longer, which sides should be shorter. Okay. All right, last topic here for the day is the triangle inequality theorem. So this is going to help you decide whether or not a set of three sides can be a triangle or not. What it says is that the sum of the lengths of any two sides of a triangle, okay, if you take any two sides, add those together, it has to be greater than the third side. All right, any two sides plus added to each other have to be bigger than that final side. So that means a couple different things. It means that in this picture, the red and the purple sides have to add up to be longer than the blue side. Blue and red has to be bigger than purple, and blue and purple has to be bigger than red. All three of those things have to be true, or you might not be able to have a triangle. So here's what that means for us. It says, can a triangle have sides with the given side lengths? Okay, so what we're looking for is if all of these statements are true. Is 3 plus 7 bigger than 8? All right, so that would be 10, which is bigger than 8, so that one is good. Okay, then we have to check every combination of that. So we have to check, is 7 plus 8 bigger than 3? Well, 15 is bigger than 3, so that one works. The only one we haven't checked is 7 all by itself. 3 plus 8 has to be bigger than 7, and this time 11 is bigger than 7, so that works out. Since all three of these work out, this one can be a triangle. Okay? If you're showing your work, that's a pretty good way of explaining. If you wanted to cite something, you could cite the triangle inequality theorem. Okay? All right, if you get all three of them to be a true statement, then you can say yes. If even one of them is false, you have to say no. So for this one, we have 5, 10, and 15. We check if 5 plus 10 is bigger than 15. We would have to have 15 be bigger than 15, which is false. 15 is not bigger than 15. 15 is the same size. It equals 15. It's not a greater than or equal to. It's a strict greater than. So this one, you cannot have a triangle with that set of sides. As soon as you get one that is false, you can stop. Okay? In this one, we're also going to have a pretty quick one because 2 plus 6, comparing that to 10, 8 is not bigger than 10, which means this one is also not possible. You can't make a triangle with those three side lengths. Okay? Last one before we make this a little bit trickier, 4 and 6 and 9. Is 4 plus 6 bigger than 9? Well, 10 is bigger than 9, so this one's good. Is 4 plus 9 bigger than 6? 13 is bigger than 6, which is good. And then is, the only one I haven't had by itself is the 4. Is 6 plus 9 bigger than 4? 15 is bigger than 4, so this one works out. Since all three statements are true, then we know that you can make triangles with those side lengths. Okay? That's called the triangle inequality theorem. They might ask you just to do it that way, or they might ask you for a range of values, and that's what we'll look at doing here. All right, last example for today. Looking at a sandbox. So a triangular sandbox has two sides that are 5 and 8 feet long. This is a weird question because you don't know what the answer is definitely going to be, but you can get a range of possible lengths for that third side. All right? So with this type of situation, I know that the two side lengths currently that I know are 5 and 8. What I do if I don't know that third side, we're going to call that third side x. I'm going to add x to the list. And then I'll show you what we can do with this here right now. If this sandbox is going to be a triangle, then 5 plus 8 has to be bigger than x. That's something that has to be true. So 13 has to be bigger than x, or x has to be less than 13. That's going to be something that we need to be true. Okay? I'm going to move some things around. 5 plus x has to be bigger than 8. When I subtract both sides by 5, x has to be bigger than 3. Okay? And then there's only one that I haven't done still, and it's kind of a weird one. 8 plus x has to be bigger than 5. When I subtract both sides by 8 there, x has to be bigger than negative 3. But we can't have a negative length anyways, and we already know that x has to be bigger than 3, so this is kind of an extra answer. Doesn't make much sense, okay? So the range of values for this one, the very smallest it can be is, well, the first length that is too small is 3. Even just a millionth of an inch bigger than 3 would be fine, but 3 is too small. So here's how our answer should look. We're writing a range of values. 3 is too small to be the length of x. It can't be 3 feet long. So x has to be bigger than 3 feet. Okay, so 3 feet is less than x, but x has to be less than 13 feet. It can be 12.99999, but it can't be 13. So 3 has to be less than x, which has to be less than 13 feet. That's my range of values of this sandbox. Okay, so if they ask for a range of values, we don't know what the answer really is, but we know it could be 6 feet, it could be 7.5 feet, it could be 11 feet, anything that's bigger than 3 and smaller than 13. So the time where you have an answer look like that is when it says range of possible values. All right, so that's inequalities in triangles. So small angles are always across from small sides, big angles are always across from big sides, and then there's this inequality theorem that we looked at last. Thanks for watching. Go ahead and try that worksheet.